Hey Peter, how's it going?
Hello, Austin.
How you doing
Great.
today, man?
I'm good. So, who will want to hear about Oracle today?
Well,
Neuracle.
yeah, I was hoping Nelly was gonna join us too, but I don't see her around right now. But I mean, as long as you're cool with it, I'll record this and I can show it to all the Scrypto class people.
Okay, so I will open the Neuracle in my challenge. So, today I will explain about the Neuracle designs on Scrypto designs on the challenge. The new Neuracle on the challenge, not the current Neuracle version.
Gotcha. Yeah. Hey, I'd love to hear everything you got. I've been going through the code this morning again. I've already.
I actually everything about Neuracle is today is a bit on NDA agreement, so non-disclosure agreement. So I cannot explain all. So I will explain the old version of Neuracle. But it's also the core. It also has the core design of today Neuracle, so it's fine. Today is just a bit of more function and some more struct to make it easier for user.
Awesome, man.
So
Yeah, I'd love to hear about the
yeah,
old design.
I will explain about the old design.
Just let me know when you share your screen.
Okay. Can you see it?
Yep, got it.
Okay. So I will explain about Oracle today. So Neuracle is a decentralized, trustless Oracle solution. I have invest research many other Oracle solution like the Chainlink Oracle solution, the UMA, or recently I have talk have a talk with Umbrella Oracle. So um, I will explain about Chainlink first and why it's have a bottleneck currently. So Chainlink solution is I must I must explain about the purpose of an Oracle first. Oracle is for people to bring data from off-chain environment into on-chain. So off-chain environment can have many data like price data, weather data, or uh, uh, time, real-time clock time data. These data don't have on the chain, the blockchain, because the one characteristic of blockchain is decentralization. But these data are centralized because there must be one. one must be from mostly from one entity to provide this data into the chain. So when you use this data, you must trust the data provider. So it's centralized and have a single point failure in this in that data provider. So if that data provider provides you wrong data, that will affect a whole smart contract, your smart contract, and will cause many people wreck if your smart contract have many users. So all these user will got their money some problem because of wrong data, like you like the real price of ETH as Ethereum is 1,000, but the data provider provides you 10,000 price data and provide you that data. So that's a big problem, and user will lose their money. So
Yeah,
that's is
oracles are
a
going to be extremely important for every smart contract
yeah.
platform.
So
Absolutely.
Oracle will solve that problem by provide you many data provider, many data validator, many bridger. So this data will get somehow mixed and through maybe through a consensus you get into chain. So that data will have a will have a decentralization characteristic because the data is not owned by only one person. So Oracle will make the data not owned by one person but a community, a network of Oracle, an Oracle network. That Oracle network will come into consensus and push that data into onto the chain. So that's the approach of many chain today, many Oracle today. Like I will explain about Chainlink solution. So Chainlink provide data on chain by a smart contract, like they call it data feed. So they have two layer. One layer is outside of the chain. That layer they call the decentralized Oracle network. The uh, the the network today Chainlink network have around 20 to 30 Oracle node to decentralize the data and come into consensus and push up data on chain. But their solution to push data on chain is they use a multi-signature uh, multi-signature transaction. There's a problem when using multi-signature transaction. Also, you can ensure that the signature is must have signed by all the Oracle node. So these so all the Oracle nodes node must have a high consensus. Even if one Oracle node don't agree on size the transaction, that transaction will fail and the data will won't get on chain on the Ethereum chain. So that's a single point failure that will break uh, liveness. That will break liveness liveness of Chainlink Oracle solution. So that's why they have to make this Oracle network centralized. These all the chain link node have to uh, make an make have to come have to go through a legal process so they can become a Oracle node. They can't be anyone. Not anyone can become a chain link Oracle node. So it's a big centralization problem.
So your solution is to make it a more
So I
decentralized
will
approach?
explain about other solution first and their bottleneck first. And recently I also talk about C-Sui Sky in Umbrella Oracle, and they they PR show to the world that they can have faster data and have batch the data in about three uh, 100,000 data pair on chain at the same time. So that's a big achievement. So I really curious how they achieve that. So here's their solution. They use Merkle tree proof. So they also have two layer, Oracle layer of chain and a smart contract on the chain. They mainly use Binance smart chain. So they have a smart contract to get data. They have a smart contract to get data on chain and an Oracle network of chain to come into consensus and feed data on the chain. The Oracle network will come into consensus and generate a Merkle tree proof. Merkle tree proof. And after have the proof, anyone they will choose a random. Actually, anyone in the Oracle network in their Oracle network can fit the data on the chain. So they have to fit the data on the chain by that Merkle proof. By that Merkle proof. If the Merkle proof is not matched with the Merkle proof that has already come into consensus, the they say that the user or as a node on the Oracle network can validate it on chain. So if the Merkle proof is not matched but is a forked proof, a fake proof, that validator will get punished. But I see that's still a big security problem since it's introduced a single point of failure. If they can fork the proof and they push on chain, the data be forked. A forked data, a fake data, can be used before they get validated. Do you know what I mean? And also they say that that's not a problem since user can also use a proof to validate their data. I say against them like uh, so wasn't that you should provide just make the smart contract operator the data feeder you give their permission to make make sure that to to ensure that the data is true or not. So what if they cooperate with the the malicious validator to get the fake data on chain? They say nothing more. That's just a centralized problem, and that's you won't need Oracle in this this case if the data smart contract operator is the one provides the data.
Yeah, that makes a lot of sense. You have to be able to trust the person that is pushing the
Yeah,
data
you
through the
have to
chain.
trust. You have to trust. When you have to trust, it's not an oracle anymore. And on Chainlink, you also have to trust, but it's a bit a bit more decentralized than Umbrella since. But I think it's also centralized, but because on the validator is Chainlink chosen, so so you
Yeah,
cannot become a validator if Chainlink don't agree with you. So it's pretty centralized.
yeah, I agree, but at least they
Yeah,
have the reputation going behind them so far.
yeah, they have reputation. Yeah, I know that because there's no better option. Currently, there's
Exactly.
no better option, so they have to use Chainlink. So I provide a better solution like this. Instead of create a two-layer solution, I make it one layer. So there will be no critical problem when you push data on chain. The data from the source will get on chain and will be validated on chain. We will get validated on chain through a decentralized validator network. So I use the serverless consensus model. I imitate the serverless consensus model to for the validator to come into consensus to get that off-chain data validated. What off-chain data? It can be from any source, like the CoinGecko, like HRD USD price from CoinGecko, for example. You can get that data. You can put you can make a request from that. Do not make directly from that data source. You make that request on the Neuracle smart contract, and Neuracle will will uh, will use the data to to uh, to notice on the validator network. So on the validator network, we'll have to fetch the data from the source, and they will all push the data on chain. They will all push the data on chain, and the data will get validated to a consensus model. So it's decentralized on chain, but not decentralized off chain. How this decentralized and trustless? This is decentralized and trustless because it's use proof of stake CPU resistant. So if a malicious validator won't use the data from the source, like they say XRD price must be $100. They feed that data on chain. But if if more than two more than 66% of the staking weight of other validator get the right data from the source, but the malicious validator get the wrong data. After they get on the chain and come into consensus, the consensus will know who is a malicious validator, and it will immediately get punishment.
Okay, so basically, what I'm hearing you're saying is that your model uses a validator style consensus, just like Radix for delegated
Yeah,
proof of stake, and just like the
yeah,
Radix validators are all coming to consensus on all of the
yeah,
transactions
yeah,
on the uh, ledger. You're doing the same
yeah,
thing with the off-chain data. So if someone does come in and say, hey, one XRD is $100, the other validators are not going to be pointing to $100. So you'll be able to tell who the malicious validator for your system is, and then basically slash them with
yeah.
with a
Just
punishment.
slash them if the data is wrong. Yeah, that's right. So
That's
it's so that's why I say maybe just let Redix use Neuracle. So
yeah. I
it's
saw that.
exactly as the same as servers. When servers, what servers validated today and and uh, and on CN is a transaction data and the message. So so instead of validate the transaction in message, yeah, uh, it says instead of validate the here validate the transaction, we on Neuracle validate one specific data in particular particular time. Why a particular time? Is because the data will be highly volatile from um, like from 1 minute Redix price can be this data, but from next minute Redix price can be different. So all the data must be have all the data must have high consensus. All the data must be the same. They cannot be different from each other. How can Neuracle do it? Neuracle can do this because it is implemented on Radix, and Radix has the ability to facilitate uh, uh, um, parallel transaction. Do you know that? Parallel transaction.
Yes.
So the validator can push the data on chain at the same time. So when it's pushed on chain at the same time, they can get the same resource. And when it's on same resource, it can get reach a high consensus model. So it will eliminate any problem, any one single point failure, like chain link, like umbrella I have mentioned.
So why don't you think these Chainlink and Umbrella Oracle solutions? Why don't you think they have not implemented their own layered, like you're saying, using delegated proof of stake
Yeah,
consensus?
they cannot do that because one reason is their chain don't have atomic composability. So the
Oh,
so
and the
so
parallelized
and the
Yeah, yeah, yeah.
parallel transaction. So the transaction fee will be will be really huge. So they cannot come into consensus on chain. That will be the cost the cost to facilitate a consensus on chain is really high, especially if they want a decentralized model like about 100 nodes. So it cannot achieve on Binance chains on or on Ethereum just because of that reason.
Yeah, it's already
So
centralized
it's
on Binance
yeah.
Smart Chain with so
Uh,
few validators. This is really interesting that you're basically
yeah.
leveraging the power of the Radix
So
system.
basically, Neuracle cannot implement on as Ethereum or Binance Chain because one reason is the fee will be really high. Second is they cannot facilitate parallel transactions, so it will be really hard. This can only done on Rick. So I will come to the code. It's okay. Are you clear about the
Yeah, this
design now?
this this is awesome. Yeah, I'm learning a lot right now.
Yeah. I will come to the code source code. It's okay to you. Any more question about Neuracle design? Any
Um,
more question?
no, not off the top of my head, but I'm sure I'll have more as you continue.
Just ask about the design. You can ask.
The one, I mean, I have been looking at this code before we started talking, and the one question I had is how you had modeled this as a second layer. Are you just kind of assuming the second layer just exists already and you start using it? I just didn't understand from your code how the second layer existed.
Second layer. You are saying about second layer, right?
Right.
Actually, it's not a second layer. Sorry, that when on the time I designed Neuracle, my understanding about blockchain and ledger is a bit not quite the same level now. So it's not actually a second layer. It's not a second layer. Another layer is actually must uh, must like I have explained about Chainlink. It's just another consensus model out of the chain spec like on Ethereum, the Polygon chain. They have their own consensus model, and they not the consensus model is not on chain, so it's not so it's
Okay, so it's not a
so
second
when it
layer. It's
yeah
just kind
it
of taking place on the first layer, but it's its own consensus model for
yeah
Neuracle.
it's taken on Radix on the first layer, and it's have its own consensus model. That's
Okay,
right.
I got you. I got you now.
Okay. So I will come to the code now. Is okay. Any question?
Yeah, that's great. We can move to code.
So here I have five module. I will come to the utility module first because it's the easiest.
All right.
So the utility module have two function. The two function will be the helpful function for when I assert the resource. Yeah. To see if the resource one is match resource true or not, or the amount match the requirement or not. Yeah. That's just a helpful function. And here a search fee too. The fee must be on the range from 0 to 100, and that's all about the utility module. Now I will come to the maybe hardest um, module. It's the main blueprints of Neuracle. Explain about these two as a non-fungible data. The two struct will store non-fungible data of validator and user. The user maybe the most user of an Oracle will be smart contract operator. So we will think the user as we take the same role as the smart contract operator. And with the validator, we have name, validator location, validator website, and the component address. This own data is just complement data. They not exactly participate on the smart contract logic, so you can ignore them. And their meaning is exactly as their name. That's name, location, website, and component address. Here about the user data. The user data will have two. The user data struct will have two component, and they are the N and the API. The API will be the API data source. I will show you what is API data source here. Uh, Wait a minute. How do I change the window? How do I change
Oh,
window?
you may have to close the stream and reopen it if you're looking at a different window now.
Okay, okay. So this is an example of um, uh, an API. An API source is actually on my website right now. So it is. I will show the address later. I will show on the VS Code the address to the link later. So
It doesn't look like it's coming through right now.
yeah. So when I refresh the API, it will get another data. It's actually the unique time data. Unique time data. The unique time data is from uh, from 1970, 1970 count from 1970. The second count from 1970. now. So you see, I each time refresh the data will advance by some second here. That's an API. I will show another API. Here's the current the CoinGecko API of current RD price. RD price compared to USSD. So current price 0.058375. I will refresh this to see if it's changed. I haven't changed. Oh, this maybe Radix is a bit low on liquidity. So
Yeah, this might not have much volatility right now.
yeah, so it's exact price right now. So I will not. I will come back to the code now. Last time about the the unique time API, I use this link. So when you on an user data, you store the API. It's actually you store the link to the data you want. So this data source we point this data source we point to the unique time data. Unique
So
time
just
data.
let me ask something here. So right there, you're saying you're storing the API, a web
Yeah,
address for the API, and then you're storing the
yeah,
exact time that you need the data from that API address.
yeah.
Okay.
This API user when user create an account, they will have you. They will be provided with this NFT, and this NFT will store the API to their requested data source. Yeah, and maybe here is one of the data user one. Actually, is the data source that I have used on the crowd finance project that have also gotten a runner-up prize on lending challenge. On lending challenge, I use this data source to calculate the the um, the borrow borrowing fee from time. So the more the borrower, the longer the borrower borrows the money, they will have to pay more. So I use the time data to calculate that.
Gotcha. Yeah.
And this is the end time. They after the end time they cannot use the data source anymore because That's how account that's about their payment. They pay maybe five five Neura. They got the same amount of time have they can get the data from Neuracle. Here we'll come to the hardest part, the Neuracle data structure. The first component is a data component. This, as it say, this it stores validated data. So after validator, all the validator network on Neuracle come into consensus, they will store all the data into this struct. The stablecoin actually is just for an example of a project use Neuracle data directly. I just use this as an example. The new version of Neuracle won't have this anymore. This is a validator struct, validator data component. It will store validators data, their component address. Each validator will have a component and their vote weight, staked amount or staked amount. The more they stake, the more people stake on the validator, the more vote weight they will have, the more stake amount. And this is a validator cap. So I actually want to design Neuracle have two stake. The stake one will have a validator cap when I want it maybe around 100, like current Radic network. So we as a first we have 100. We will choose the data. We will validate the data from 100 top validator. So and ignore the rest, like current Radic network. And after the stake 2, on the stake 2, we will remove the validator cap and we will use on the validator. Sorry. Oh, someone coming through their voice. Hello, Eddie.
How's it going, Eddie?
So continue. I will on the
Hold on 1 second here.
what's that?
You may have to right click on his picture and mute him if he's making noise there.
Maybe I mute him. Sorry. So validator cap is removed on the stake 2 and we will use on the validator stake amount to come into consensus. When on the stake 1 we will use a cap like around 100 top validator to come into consensus. Or we'll store the Neuracle token. The controller batch will store the Neuracle component controller batch. The batch here will be used to mint and burn the Neuracle token for when user request the data, they will have to burn an amount of Neuracle of Neura token, or to punish malicious validator. This stack will be slashed and will be burned. Or the mean function will be mean when we reward the validator for their work. The Neura token resource address, the validator batch resource address, the user batch resource address, the pay rate. The pay rate is the amount of user has to pay per data feeding round. A data feeding round is actually around when all the validator will come into consensus. So all validator will have a time gap to like around 1 second or maybe lower than that to make a transaction of the data. When the round start, when a round start, they will have to uh, push or get the data from option source and push that data on their validator component. And the Neuracle here, Neuracle blueprint will get all the data from all the validator and uh, and uh, validate the data by making all of them come into consensus and see which data has the most staked amount, and only validate the data if it has more than 66%.
So are you saying
So
that they have a like a full second or some period of time to actually make the transaction go through once the data is
so
validated?
I have a threshold. I have a threshold. I on here I chose wait on here I chose the validator can only advance the check on active status of validator and can only advance if more than 66% of validator is active. So when they make a transaction to push the data on chain, that will make the validator status become active. And when they become active, here active data on validator component. When they become active, so when more than two 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 per tree of validator is active, uh, so people can call this method to end around and to make a consensus model work, so the data will be validated. So it might have a time gap, but don't exactly um, don't exactly depend on uh, um, a pre-chosen time gap, but it's depend on the in actual it's depend on the validator's node system requirement. If their computer, their node work fast, they will make the transaction fast, and if they slow, they will make the transaction slow, and on the transaction will be execute on parallel, so we don't have to worry about that. So the pay rate is like if you use if you pay rate is Neura. You will when you burn one Neura, when user burn one user Neura, they can get data on one data feeding round, on one consensus round. It's just like block on blockchain or epoch or anything like that. The fee, stablecoin fee. So the fee user has to pay for ecosystem when using the stablecoin project. I will explain this later. The unstacked delay. So unstacked delay is just like the unstacked delay on Radix network. Is an extra security feature to prevent people from just unstack and sell their token, and is to ensure the people to consider to carefully choose the validator before they stake the token. The stake, as I explained it above, the initial state is stake 1, and we will have a validator cap, and on stake 2 we will have no more. The round length. This is a frequent series of round. So after each consensus round, there will be a time gap before you can go on to the next round. It's just like the heartbeat feature on Chainlink. So to prevent, we just go on a fast round, and round and round to the next round. Each round will have to do many things to ensure a consensus. So it will be really fee costly on Reddit, on any blockchain. So we have a time gap to prevent that. if we if we will just come into the next round after the first round, the fee will be really costly for validator and for anyone to run the Neuracle at the same time. So we have a round length program to prevent people from just go from a round to the next round. So maybe on the high fee layer, on the high fee blockchain like Ethereum, this round length or heartbeat will be really high, like on Chainlink, on Ethereum, they will validate the price data each half an hour. So it's really costly, so they have to do that. But on Radix, if the fee is low, we can keep the round length low, so we will have the data stream live. The data stream is fast, so there will be delay on time data, on the off-chain data. It will not be live data. It will have a delay. So that delay will depend on the round length. The delay on Chainlink is half an hour. So after each half an hour, the price like Ethereum price will get updated.
So the shorter the round length, the more often you can get the prices
Yeah, the
updated, right?
more often, not more often you can get the data. You can always get the data, but the shorter the round length, the more frequent you will update the data. So the data will be more live, more live that way. So it will depend on use case. Maybe some data will not need to get high frequency, update frequency, but I use the price data reference, so I will
Yeah, so
really want
price
to have
data seems like it
low.
should be updated very quickly, whereas if you're getting something
Yeah,
just like weather, maybe every 30 minutes is not the end of the
yeah.
world, right?
But I use the price data as a reference, so we on Neuracle we want the data to get update on the most frequent as possible. So on the consider of the fee cost. But current Scrypto version only allows the using of the epoch time unit. So the lowest round length can po- possible on the version, the I think is 0.4 Scrypto version, and also today version 0.5 version is we have to use the epoch time unit. We don't have any other time unit. We don't have clock time. We don't have uh,
Surely clock
mm,
time will be something we can use in these types of circumstances at
yeah, but
some release in Scrypto, right?
you know that clock time is off-chain data. You
So,
know that, right?
right. But I'm saying, like,
Uh,
surely future releases of Scrypto will have units of
yeah,
time smaller.
maybe future we will have. I don't know how they get the time data on Scrypto, but if they can do that, so it will help Neuracle a lot, and a lot of other smart contract will be built on by Scrypto. So let's forget about the limit of time unit right now. So I will use as an example use one epoch here. Estimated 1 hour per data update is really big for for Pi data, but we don't have other, so
Yeah, you got
just
to
use
use
other
the
data.
tools you have right now, right? Yeah.
Yeah. So and the reward rate, the inflation percent round. Round will have an inflation. So all the inflation will be emission for validator node to reward for their work. So if there is 0.0015 and one round is around one epoch, which is around 1 hour. That's about 13 API, 13% API. This is an economic feature. Punishment to an economic feature to slash the untrustful validator. So untrustful validator will be punished 5 times the reward rate. The Neuracle system time. So this will be counted from 0 to it's actually the current epoch chain. the round count, the round count, round counter. So if Neuracle come into consensus, we on the first time the system time will be one, and second time will be second, and follow. Keep track of the route status, route start or not. This data struct is for validator to see on the Neuracle or any option like Neuracle gateway, like to see if the route is start or not, so they can fit the data on chain. They can only fit the data when the route start, and if they are late on update the data, they will be deemed inactive, and they maybe will miss the reward on that route. So they have to keep track of the data of this struct data. The active validator. This will store the active validator of the route. Will eliminate any validator first, not on the validator cap, not on the top 100 of validator count by stake amount, or the validator is haven't updated the data, haven't pushed the data on their validator component.
So the validators that are being used, like you say, the top 100, are selected at the start of each round, basically.
Yeah, that they will be selected on the start of the round. I will explain about the logic later. And the mean controller batch. Uh, this is for the stablecoin project. You mean you to burn the stablecoin. Burn the actually it's use the stablecoin. This stablecoin project use exactly same model as Luna. So I don't want to talk about that too much, because that's a failure.
I got you, no problem.
Yeah, it's use the same as Luna. You know Luna?
Yeah, I read your explanation that, if you just swap into the stable and cash out, you're just basically making money off of the inflation rate of whatever your base currency is, which, makes sense because that's kind of what
Yeah,
happens.
this design exactly that, and when you swap, you mean new neural. When you swap from Neuracle to stablecoin, you burn the neural. When you swap from Neuracle to Neuracle, you burn the stablecoin and mean the Neuracle. So it's a unstable version of algorithmic stablecoin. So I don't wanna to talk too much about this design. So now we will come to the function and method of Neuracle. First, the Neuracle will the new function will create new component, Neuracle component, and it's use a medium token. Any token can become the Neuracle medium token. So if you have maybe Austin token, you can fit the resource address on this blueprint, and make the Austin token uh, an Oracle medium, and it can have the function of to use in the Neuracle smart contract.
All right, I like it.
And admin batch. So the admin batch is What is admin badge? Forgot it. Admin badge like resource. Maybe you have a badge, and you want to control the Neuracle smart contract. You have to fit it in resource address here, so you can control the smart contract through many methods like create new validator node, advanced state, set unstack delay, set many param I have mentioned above, like route length stablecoin project, or create new stablecoin project, or create new no, or set unstack delay new advanced state. Why new API need controller? I will examine it this later. Next, the mean control badges. So this is created from you create the Austin coin, and you have a mean badge for Austin coin, and you fit it on the Neuracle. And control badges too. The control badge can mean or burn the Austin coin. The initial validator cap, I plan to have it like 100. The route length, I plan to have it like 1 epoch. The pay rate, I plan to have it like one neura for one round. User will use one neura to have one round of data using. Fee, stablecoin fee. The fee when you use a stablecoin project, and unstack delay maybe 500 epoch, like current Radix network. Current Radix network have 500 epoch unstack delay. It's around 2 weeks. Reward rate for validator, and punishment for malicious validator. Now here I will explain a bit about the logic. First, you get the system time by the current epoch, divided by route length. If current epoch of the network is 0, maybe, and the route length is 1 epoch, then the system time of Neuracle will be the same as the network. The Radix network time is 0. The access fee, to make sure the fee is on the range of from 0 to 100. Create new controller batch. Actually the mean controller batch is for Neuracle to mean new controller batch to mean and burn the Neura token, mean and burn Neura token to fit on the new Neura stablecoin project, like here. It will be fit on here. It will be fit on here when it create new stablecoin project. Like if like the Luna project, maybe you want your token pack to USD. You create new component and provide it a batch to mint and burn your token, and maybe you want pack it to as as a fiat like the GBP or any other. You will every time you will have to mint new controller batch, and the controller batch will be used to mint and burn the Neuracle token or the Austin token. You understand that?
Yeah, I'm following.
If anything you won't get, just ask me. And here's we create a validator batch. Validator batch will be a non-fungible and can only mean by control batch. Mean burn and can only update by control batch, and it had no initial supply. User batch also. I will explain this later because it will be related to the methods below and store all the data here and here into the new component structure. And as a notice, on the new version of Scrypto 0.5, you won't use this model, this instantiate model anymore, but you use this like this.
Yeah, you can't instantiate and globalize in the same
You
step.
must instantiate first, so and you add access check and globalize later. Yeah, it
Yeah,
will be used like
I've
this.
been going through trying to edit my old code to work with the new Scrypto version. It's not too bad of a change.
Yeah, and we will come to the methods part. Create new validator node. You will have the name, location, website, and fee. The fee for validator node is exactly like the fee when you stick on the new on validator on Radix network. So when Radix network have emission for sticker, you will have to pay a part of your stake to the validator. Part of your reward to the validator. So the fee will be used exactly that. So the validator ID is random, the batch, and its data structure. Well, resource manager to mean new non-fungible and create new validator address to the validator blueprint here, new. I will explain this later. New Neuracle token. Yeah, I will explain the structure of validator component later. And validator data. And here I have the component address as default, and here I store the address in the here address on the data later. Here update the data as a new address, and I push the new validator to the validator struct here. Any question about this method?
I don't think so. I think I understand it so far.
Yeah, and this is become validator. There's a create new validator. Actually, the create new validator can only be called by admin. Why it have to be called by admin? First, to prevent the CPU attack, Neuracle also needs to use the delegated proof of stake mechanism and through only validator that has a basic requirement of network traffic and security. So as I have mentioned above, if the validator is too slow to make a update data transaction, the data might be wrong. So on the whole ecosystem cannot come into consensus if their computer or their node not meet the requirement. They must meet the requirement. So it's the so it's a HR security feature on step one. And after Xi'an, um, after the Neuracle system is more decentralized, now you don't have to worry about the ecosystem, about the validator network anymore, because uh, people, the stickers, can easily choose which validator is more have more commitment or have uh, truthful or more uh, uh,
The
mm,
stakers will be able to pick the best
will
validators they
be able to
prefer.
pick
Yeah.
the best validators, so won't have to worry about that anymore. But on the first, when you launch the Neuracle project, it will highly centralize. You will have must you have the extra security feature like this in your validator node. And after CN, you become more decentralized and you ignore that. And the stage two and stage one. This was stage one. And as an admin, you can choose when to advance the state here. These two method is exactly the same except the assert assert lie here. Next, become new user. Anyone can become new user and request new API data source like web link. I have show you an example, and they also have to pay an amount of Neura token to burn to get their length, their periods. They can get the data. The more they pay, the longer they can get the data. Get the payment amount and assert if the payment is the same rerush and meet pass the minimum requirement or not.
So is this badge that's created on the become new user method, is that just good for the one request for the Oracle to push the data,
No,
or
it's actually more complicated than that. So when you request an API, if the API is not is an old API, like it had existed on the on the network, on the Neuracle network, it will not store the new API on the Neuracle anymore, but but it will just provide you the NFT. And if the API is not existed on Neuracle network, like you use a new data source, have never and never have any user have use that data source before, then you will insert new the API source into the the data structure of Neuracle here. And you shouldn't use the data on your first create for your first create, because that data will be default. That will that haven't come into a consensus yet, so the data haven't gotten validated on the Neuracle yet. So you shouldn't use the data on this time.
I gotcha.
But the old data is already validated, so you can always use that. Yeah, if here I check if the data is already on the Neuracle or not. Yeah, checking if it had if Neuracle has that has the API or not. The math here. So we divide the amount of his pay by pay rate, and to see how long, how many round these people can use their data, and their length, their round amount. Yeah, round amount. Uh, Multiply by route length to get their epoch that they will they will have to end their account. Their account will be end and they cannot get the data anymore. Current will be calculated by the current epoch plus the length they can use the data to get the end time. Did you have any question around this?
No, I don't think so. I think I'm still following.
Okay, I will move on next to the definite count, and you when your account is already run out of resource, you cannot get data anymore, or you want to refund your account so you can use the data more, you have to use this method. Or you can just create become new user and create new NFT, but I think that will be more fee costly. So here you provide your identity bucket. Actually, you should use proof on the right model on this method. You should use proof, but I on the challenge the challenge time I haven't got how to use proof yet, so I still use bucket here.
So is your when you're let me see how to ask this. When you make a new account and say you want to do multiple things with Neuracle, like you want to check the XRD price and you want to check some other token prices, you can use your same user account and your same amount of
No,
funds.
you cannot
You cannot.
use the same user account on some other data source, because you see here the data source is stored on the
It's just
user
for one
struct
API
data.
then.
Just one API.
Okay,
But
I
this can
gotcha.
be like this. But this can be like this. It is more complicated design, so I will not explain this here.
That makes sense. You could do
Yes,
if
you
you
can
knew ahead of
always
time. what all
Yeah.
you wanted to query, you could make one account for all the separate things, but you'd need to know ahead of time or something.
Yeah, you can have one account for for more than one data source and many ways and any way like that. But I think that is not economic viable design because as you as you use more API, use more data source, the validator have more work. But if validator have more work, Neuracle have more work, but you pay the same. That is not economic viable. So I
That makes
don't use,
sense.
yeah, I don't use that design here.
This is just crazy. Like, I don't know how you sat down and considered all of these different circumstances. This is wild.
Yeah, I participate on the challenge exactly how I explained you from the first time. First, I research what is Oracle and what is its current challenge. I research about chainlink problem. I research about many other problem, and see that Oracle couldn't have a trilemma. And I after get a trilemma, and I use my creative mind a bit to see how I can solve the trilemma by a smart contract design. So I come to the Neuracle design, and I draw the Neuracle design here. It's long, so I will. You can read it on the challenge page.
Yeah,
So I
I bet I imagine just the amount of research you put into this was
yeah.
weeks worth.
You you have researched a lot before you come to a design. Maybe at that time, maybe I got around a week, maybe a week. Yeah, whole 7 days to get to the Neuracle design, and 10 more days to develop this, and uh, uh, maybe no 10 days to develop this, and the test on the transaction manifest, and uh, test the logic and fix bugs and anything. And after I have happy with this, I come to the front end. The whole 13 days for the front end.
Wow, yeah. See, front end is still way beyond me. I hadn't even touched any of that. So
Yeah. So I have also I have also give suggest for people participating on the Scrypto class that the workflow they suggest a workflow for people if they I have divide the workflow like the design phase to research and make a clear design, and the code phase and the test phase and the front end phase. Uh, and after you organize the work like that, you will have a workflow and you will follow the path very easily. Actually, the hardest part is you come to a best design you can afford. So and that design must also be logical and can be used on Radix. So that's the hardest part. And I have always has a logical part. Uh, I maybe I have a bit good grade on math. So come to design is that phase is a bit easy for me.
Yeah, so that brings me to another couple questions for you. What exactly is your background? Like, what do you do? What do you have a degree in mathematics or anything?
Have you read my Scrypto journey?
Oh, right. I need to get back. I did read that. I need to go back and link that in this video. This so other people
Yeah,
can. Yeah,
actually, I
yeah.
have no coding background. I have no coding background. But everything I can show you here, everything is that I have a I can only say that I have a great mathematical mind. So I really it's really easy for me when working with logic. So when I read about Scrypto, when I read about all the Neuracle design, or when I come up to the or the Oracle design, or when I come up to the Neuracle design and make all it work on one design on the Neuracle design by making it logically, it's on maybe on come from my mathematic background. I have no coding background, but with the mathematic uh, skill, I think it's pretty easy to learn Scrypto when you read about the component and resource and batch and anything like that, and do example and you learn everything like that.
Yeah, I guess I'm sort of in a similar boat. I have, a mathematical background, but I've obviously
And
never done
uh,
any coding at all before Scripto. But you seem to
and
be picking it up a little bit quicker than I am, which is awesome.
yeah, actually, my mathematical background is come from my uh, uh, what is uh, uh, after kindergarten they call is after kindergarten, which type of school you go to? Oh, just explain this like this. This I went on grade five, grade five. Went on school day, grade five, and I got first place on mathematics. Uh, first prize on math at the province level on my country.
Very nice.
So yeah, I have a math my since that, and even on the even gone when uh, I take the national exam to get into university, I also got 9.75 per 10, so it's almost 10. Almost 10,
Very
so I
nice,
got
man.
almost all the question right. So on math I can proud that I'm a bit good, and
I'm sure that's really
so
helped you.
maybe that help me with on the logical on the design and help me
Yeah.
come up with Neuracle. That's why I also say on my Scrypto journey that if you want to take on Scrypto journey, maybe a coding background is not needed, but you would need a logical mind, and maybe mathematical skill will help a lot. So if you're not good with math, so you will your Scrypto journey will be really hard.
Yeah, I'd agree. I don't think you need like in my engineering classes, I'm doing I did partial derivatives, I did all kinds of really crazy math, and there's not actually like super hard math that I've come across when looking at any of these crypto challenges. It's not like super complex math, but the more well versed you are in math, the more I think you tend to understand the logical
Yeah, you
side of
would
things
not.
better, and it would probably make
Yeah,
the logical coding a lot easier.
yeah. Actually, on coding, you would not use the math very much, but you use logic when you is fluent with math. You also fluent with logic, so it's just
Exactly.
logical that way. So, and when you fluent in logic, you can learn any language. Like how I learned the front end here. Front end is also a big, it's really hard for me. So
Yeah, I don't. This is.
even
I
now
can't
I
understand
take,
any of the front end yet.
even now when I I I look back at the code and I always ask myself, what the fuck is this? What I have code?
Yeah, it's probably got to relearn it just to look at it, huh?
I don't want to look at that. So next to the continue to the Neuracle methods. So you have a get data method to for the user to get data from. The data will be in string format. So it will always be in string format for the general case of data using, because the data from off-chain environment from your from your from your API will always be a string. Will always be a, a HTML string, string, a line of string. So I will just fit the right data format from each source here. So it will always be string. But if you want to use a decimal, you can just use like this. Oh, yeah, it's done. You get your decimal. Oh no. Yeah, and you get the decimal. So the use a move value. Fuck. So so the data format when you get data will always be string. On your smart contract, you can always use something like this line to change the string data into decimal. Anything you don't understand,
Oh, I'm still
and
with you.
you provide the yeah, provide the user NFT. This should be a proof. This should be a proof, and you not return the identity, but you just drop the proof
Yeah, that makes
and
sense.
get the user data and check if the data is n is already n or not. If it then n, and you cannot access the data. Now we will come to the hardest part, the consensus model. So after a time delay, round delay, maybe from the last round, or you just go the first round of Neuracle, first consensus round of Neuracle. Anyone can call this round. Why? Anyone can call this round, and I just make anyone can call this round to make sure that the round will be called right after it pass the time delay requirement. So to process a round, someone must call this function. Someone must call this method. It can be admin, or it can be anyone want to reward to take the reward amount for people. This is the what do you call uh, so the reward is for anyone, so it to ensure that people has the right incentive to call the Neuracle round, to run the Neuracle. And here is it logic. First, it check if the current time is past. Current time has passed the the last the last the last round, and that's yet the last round and will the last round and plus the round delay will be stored on the system time after the end round method. And also check if the previous round had ended yet. So you cannot call this method twice. This method, when you call once, it will make the round start true, and round start must be full to be called this round. So this can only be called one each time. After and here is a logic. So you will be the Neuracle will outright to all the validator with its validator address and weight. It get the current stake value of that validator, and make the validator have the round start status, so they can update data now. They cannot update data if a round haven't start.
So what happens if no one calls the method to start the round?
No one call. Maybe admin will call. It will have a right incentive. Yeah, the person will be rewarded a pay rate amount.
Okay, yeah,
An
that
amount
makes
of
sense. Okay.
So anyone can call it. They have an incentive to call this method. So I don't think anyone don't think there will be anyone that don't want free token.
Exactly. Yeah, that's cool. I didn't think of it like that.
Yeah. So it will call and make and get the weight of validator, and make the validator round start, and so they can update data. Yeah, we will mean a bit of error to reward the caller. Round start. Here we set the round start. So you cannot call this again and get the reward again. You cannot do that. You cannot only do that once. So if the stake is one, you if the stake is one, you choose the top validator by cap maybe the cap is 100. You choose a cap from validator from 1 to 100 by the stake amount. Here is a logic to sort the validator. Yeah. You store the validator by their weight. Update the weight by the newest weight. And you short the validator by its weight from top to bottom. From bottom to top. Here you short from bottom to top. From lowest stack to the top stack, and you reverse it to get the top from the bottom. To get from the top to the bottom, and you get from 0 to maybe 100 here. Get from the top validator by stake amount. And if this try get cap function, maybe the validator is not 100 but actually maybe 99. This try get gap will get known. Try get gap will get known, and the smart contract logic will just store the active validator by own the validator here. We will store own the validator on the active validator, but it have a cap maybe 150. You choose 100 from 150, so you choose it from x here, from the number of validator cap. Else, if the stake is stake 2, you on stake 2, you just store on the validator. You don't have to worry about that, because on stake 2 you will come into consensus from on the validator on the network. So you understand that new round now?
Yeah,
Any question?
I'm following.
Okay. So I will close the workflow here a bit, and I come to the validator. After the round start, validator now can update the data. So there's a stack and add stack and show stack, chosen stack and unstack, and show unstack, record stop unstack, withdraw. Many for method here is just for the proof of stack, for the stack logic. Here, the update data method. You can only update data if the round is start, as I point out here. Here they will set status of own validator as round start, and they can so the validator can update data here. If the round start is true, they can update data, and they can only update data once, since at the end of the logic it will set the round start false, so they can only update once to ensure the uniformity of the data. After they update the data into their struct here, the new data here, the new data here, and they will set their status as active. They will be active after they update the data. And also the round start method will also set the validator inactive. So they have to update they have to update the data to so they can become active here. On route start, new route, validator will become inactive, and we will set the route start status so they can update data and become active. If they don't call the update data method, that validator will be deemed inactive on that route. So now we will presume that all the validator on the network have updated their off-chain data on their component here, update the new data here. But this data is haven't validated. This data is the from one validator. So that validator may be malicious. You shouldn't use the data from a single validator. So the end round method will get the data from all the and no, it will first check the validator, check their status if they have active or not. Here it will first iterate to the active validator, have screen out from the new method function here iter true, and will get its status. If it's active, it will return true. If return true, then we will store the it address and its weight on this for on this for here. Store the address of the active validator and weight. If there is at least there is more than 66%, 67% of active validator, you can process to the method, and if not, it will just panic and you will cannot call this method. This is just to ensure that there will be no malicious validator. Just update the malicious data first before any other validator, and they just call the end route function. And all the validator haven't is inactive. Maybe most can be is 23% of inactive validator. They might not get the reward. Here now we will again store the active validator as the screen it out here. We screen it on the inactive validator. Here we create a own data struct that store all the data, all the data. Here is the API. Here is the new data of that API, and the map for the data by it API, and the weight of this type data here, and the total weight here. So it iterate to on the active validator. It gets the new data from that validator. If the own data var here already have the same data as a validator have validated have store on its component, it will just plus their weight on the previous weight, or else it's a new new map of data. It will store new map of data. It will insert new map of data on the old data hash map. And the total weight will always be the total weight of on the active validator. Here we will sort the old data by its weights, and we choose only the data with the most weight. Here, the data of the hash map that has the most weight, and here is the weight of that data. If the weight of that data is more than 67% of total weight, then the data is validated onto the Neuracle component here, and we will reward any validator have the same data here. If the validator is the same data as the new data, it will be reward new token, and if that's not the same data, they will be punished here. The new consensus round Neuracle and you choose new system time by the round length, and you +1 to ensure that the new round will only be called after this system time. So after a round you set the round start false, and you mean a reward for people who call the end round methods. Any question about this method?
No, so you're rewarding people for ending the round, and you're rewarding people for starting the round.
I rewarding people for either ending a round or start a round, so it can be happen right after it meet the requirement. The requirement for new round is they have to pass a delay and pass the system time like this, and the requirement for ending a round is there must be at least 67% of validator active.
Right, I gotcha.
And here's the new stablecoin project. The stablecoin project will use API is exactly the price data of Neura. If it had one Neura versus USD to produce a new stable coin, like I call it the USDN. But it's actually use a lunar model, so it's not viable. Has proven not viable here.
Yeah, I gotcha.
So I don't want to talk about this part here. The data, but I will talk about this data. It will use the price data. price data here. You use the price data from Neuracle here, get data. And you parse the price data as a string format to the decimal format. Current price, you get the current price, and you swap by that price, and you mint and burn token according to the price. And as you know, people can always always get profit from from the inflation of Luna token. So that's what makes the failure of Luna project. Here's some useful function. Show validator to show current validator. Show API to show current API. Show stablecoin project. Get the on the API or advanced stage. Advanced stage here can only be called by admin. Set and stack delay can also called by admin. Here too, set route length can only called by admin. So if you feel that people fine, if you set unstack delay is like 100, you can set that, and people can withdraw their token after unstack after 100 epoch. And you can also set route length. If you feel that one epoch per data consensus route is a bit costly for validator and for the Neuracle ecosystem, then you maybe set the route length more, maybe 2 or 3 epoch. Now I will come to the but first, any question about the Neuracle blueprints?
I
Any
don't
question?
think so. This has all been really fascinating to listen to, and like to see you program the logic for the actual, like how the actual validator system works on Radix, to see the logic in Scrypto is really interesting to me.
Yeah. And here I will explain about the validator blueprints. The validator blueprint has the stacker non-fungible data. So this stacker non-fungible data will store the stake data of staker. They have the address for validator component address, the validator name. These two data will not participate in the smart contract logic, so you can ignore that. The unstaking amount, if they are unstaking, there is unstaking, or the end time of current unstaking. If after the end time you can withdraw your token, and unstaked is the amount available for withdrawal. The validator will store the staker data, of course, and their stake amount. The validator name will not participate in the smart contract logic, and the fee for the validator exactly the same as the Radic, and unstake val, and stake val, and fee val, and control batch, staker batch, medium token. You can use Austin token for staking also, and unstake delay, and data. Unstack delay is just that get from the Neuracle. On the validator on the Neuracle must have the same medium token here, the control batch, the uh, the validator not exactly the same, the name fee not exactly the same, must have the same unstack delay here. The unstack delay, the data got validated, got pushed onto the chain. Sorry, got pushed onto the chain from that validator, and route start and active status of the validator. Here's a function to create new validator. The medium token must be the same on Neuracle. The batch's address is exactly the validator batch's address here, created from here. The neural controller batches. This neural controller batches will be used to mint and burn the validator stake amount to slot or reward the validator. The name, the fee as they choose, and unstack delay get from Neuracle. Here we create new validator. The neural resource, the validator batch, the controller batch, the unstack delay, and name and fee will be chosen. So the fee, and so the fee is from 0 to 100. New controller batch. The controller batch will be used to mint and burn and update the staker batch. The staker batch will store the staker data. Here is structure, data structure. Store on here, on the data here and here to its data structure. It's not the same on Scrypto 0.5 as I have explained.
Right.
Now we come to explain the stake model of proof of stake model on Neuracle. So you can stake here. After you use an amount of token to stake, you will get the staker batch to keep track of your stake. Yeah, your assets, their loss, and resource, and get new non-fungible, and return the batch for the staker. And you can add stake to your batch here. You provide the identity batch, your staker batch. This should be approved. This should be approved. Should be approved. This is just an old version, so I haven't changed this to prove that the token bucket, how many you want to add to your staker. So the batch data will be updated according to your stake amount. No, actually your stake amount is stored here. Just your stake amount is stored here, but not here. You not store the stake amount is not stored on your on your batch, but store on the validator component. This is for easier for the validator or the Neuracle smart contract to get the total stake value. They cannot get the total stake value if the stake data is stored, the stake amount is stored on their batch. You know that?
So
Actually,
the
there's,
unstaking amount is stored on the badge, but the amount you have staked is stored on the
yeah,
validator component.
yeah, the amount of stake is stored on the validator component, but unstake will be stored on the batch. Actually, with 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 the resource manager, you can do that, but I
Yeah,
don't
I was
know
just
how.
curious, why wouldn't you store everything on that one badge, like how much you have staked as well, and then somehow take that metadata from the badge when you need to know how much is staked?
Uh, yeah, you have show my stake amount. Yeah, method. So you get the ID and get the ID by the map here. You will get exactly your stake amount. Any question about the stake methods?
No, I don't think so. It's just I'm gonna have to go back through and look at all of this in more detail, I think.
Just ask.
It's like
And
I guess my question is, why wouldn't you store the staking amount? Like what I heard you say it's easier for the smart contract to determine your staking amount if you're storing it in the validator component, but I don't understand why it is easier.
actually, you can do it like this. Um, this is another method I can show you. Actually, there's many ways to do this. Like this stake amount. You store the stake amount here on the batch, and you will not store the stake amount here anymore. Oh no, you have to. So sorry, you have to store the stake amount here because there is a punish and reward methods later. I will explain later, and the 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 punish and the reward methods will exactly change on the sticker data. So it have to store on the validator component, or the validator cannot change their stake amount by their reward. You know that?
Okay, okay, I think I understand that now.
So validator cannot reward staker if the stake data is on the batch. The stake data must on the component for the validator to reward them. At the current stake value for the Neuracle component to call. Here is the unstick method, a bit complicated. And this method will check if we first check if you are currently have a unstaking and jet. So if you have an you are unstaking and it's have ended, you will it will update your data like this. Your unstacked will plus unstacking, and your unstacking will be 0, and your n will be 0. You will have no so this method will make the stacker status from unstacking to no to to uh, to withdrawable status, so they can withdraw their unstacked token. When their token on unstaking phase, they cannot withdraw, but they have to wait unstaking delay. After the delay, they can withdraw from their unstaked amount here. It asserts if they already unstaking something or not. If they are already unstaking something, they must stop unstaking, or they have to wait until the unstaking is end. So you cannot, so a staker cannot unstack many times at the same time. They cannot unstack one neural and two neural and three neural later uh, on on their unstaking delay. They cannot make three requests on one when they are waiting for the last time. So they have to wait for their unstaking of one neural, and so they can unstack two more neural, or they can just end the current unstaking phase and request new unstaking phase, like you end the unstaking of one neural and you create new unstaking requests of three neural.
Okay, so you can do the second request after canceling the first. It just kind of resets the timer then.
Yeah, you can reset the time to make a second request, or you can wait. Yeah, is you don't have an enough amount of stake to unstack. If you have enough amount, it will be subtract the amount you request, and it will calculate the end time of unstaking phase and update the data. Update the data. Any question about this unstack?
No, the unstaking actually
Any
makes sense to
question?
me.
Okay. Show unstack record. So this will show you are current unstacking or not, unstacking how much. Stop unstack. This will be the same as the unstack. This will go to this method, this process. It will check the previous unstacking if you have passed the end or not, and store the unstacking onto their unstacked, so you can withdraw. And will stop. And if it haven't passed the unstacking, so it will stop your current unstacking and push the stack amount on the component again. The withdraw method, you can only withdraw if you have the unstacked amount here. This method is the same as the stop unstack and the unstack. This line here, we check the end. and store the unstacked on your data. The update data for validator I have explained on the consensus round previously. Round start. This update data can only be called by validator. This round start can only be called by Neuracle smart contract. Why? Because I have it here. This must be authorized by the control batch, or you cannot call the round start method. This to prevent validator from just setting their round start status and update new data. Get status for the Neuracle smart contract to get the validator status. Get data. Mean and burn here can only be called by the Neuracle smart contract. Here, the control the batch have to authorize to mean or burn. The mean method is for reward and the burn is for punishment. The mean first, it will minus the fee for stacker. It will mean the amount of the total amount of reward for all the stake on the validator. Put the fee on the fee vault, and for each for each sticker it will multiply their sticker stake amount by the sticker rate here. Calculate here. Do you understand this math?
Yeah, definitely.
The rate here is the reward rate. As I have an example above, like 0.0015% is around 13% API. Burn to punish. The burn will have no fee. Sorry about that. So you finish on the sticker as a stick and diminish the stack by a rate provided by Neuracle. Yeah, punishing rate here. Chain fee can only be called by validator and withdrawal fee also. Any question about validator, Rupert?
I don't think so, man. This has been a great explanation of everything you've done.
Okay, and the new Neura token here, or it can be Austin token. It's fine. Austin token here, and this is to create a new token and admin batch and the mean control batch for to fit in the Neuracle to create new Neuracle smart contract. So it can be Austin token. Austin token can also be a Neuracle, or can also be a Oracle smart contract and provide Oracle solution for everyone. and the stable coin. I don't actually want to go to the
Yeah,
design,
I
but I have
understand. If you've already even taken that completely out, yeah, I completely understand not even
yeah,
looking
but
for it.
I have explained about how it gets the data from Neuracle here and use the data here, use here, and to the map will use the price here to calculate the swap amount or the lunar lunar type of algorithmic stablecoin, algorithm stablecoin. So I have go to on the Neuracle design. You have any question?
I think you've answered just about every question I had. So are you? I assume this is going to be a project of your own that you're going to be developing your new design, right?
Yes, I am currently develop new design of Neuracle, but basically it will use the same consensus model.
I am really excited for Babylon to come and to see everyone's new designs like this. Like, I don't think people will understand that the design that you're using for Neuracle is only possible because of how Babylon is going to work and how, you know.
Yeah, it will highly depend on Babylon. So I really hope that it will have maybe have low fee. So low fee like right now. So it will not destroy my smart contract logic.
Yeah, I understand that. I think there are going to be so many things like this that are going to be possible on Babylon that people don't even understand about. Everyone's going to be used to the existing like chain link model, and I'm talking about more than just oracles. I think there are going to be things that people don't even understand right now that are going to be possible in Babylon that are going to make things so much easier. So I'm very excited for that.
So Oracle is a great solution for people or smart contract operator to get their uh, to get the data from off-chain source, and I can provide a bit of information about current Neuracle designs as also as I'm currently design more functionality for Neuracle. Uh, Current Neuracle design can only get uh, previous Neuracle design can get data from any API source, but as a new on the new design of Neuracle, the current design can can have on the three functionality the same as the most reputed Oracle solution like Chainlink included data feed from any source like Neuracle right now. Um, uh, V SRC secures randomness computation to get randomness from off-chain source, and the third functionality is automated smart contract function to facilitate automated smart contract function and call the smart contract based on off-chain source. Is like for the SRC, the secure randomness function, you can get the randomness for maybe gaming, betting, or um, minting NFT and ensure the NFT is minted randomly, not uh, not manipulated by the smart contract owner. That they will always mint the best NFT for their pupil, maybe like that. And the secure randomness computation will help you with that to have more decentralized randomness for gaming, betting, and NFT. And for the uh, ASF, the automated smart contract function, you can have many automated smart contract, hybrid smart contract like uh, automated flash run opportunity trading or automated token vesting or many things like that. So it's participate and uh, participate on building Neuracle and also using Neuracle as a first smart contract operator of Radic ecosystem will be really benefit since this design will also more advanced than current many design like I have explained above like umbrella or chain link. So I also uh, mm, inviting people to participate on uh, review and finalizing my paper, the Neuracle point to point Oracle network for next generation smart contract. So you maybe you can people can participate in uh, and build the Neuracle together. You get the reasonable reward for that. Uh,
That's awesome, man. Yeah, definitely.
yeah. I have posted the message on the on the media platform on Radic, so people can participate. Maybe people who watch your video can participate too.
Yeah, absolutely. I think you'll find lots of people that want to help out with something like this, and because if this is realized on Babylon, this is going to be uh, an amazing thing to have a decentralized Oracle available.
So, any more question?
I don't think so, man. I just want to say thank you so much for spending your time going over all of this code, and I know that things are not quite up to date with the Scrypto point 5 since this was done beforehand, but the changes between now then and now are not too severe. I hope everyone who watches this has picked up a thing or two about how your design works and just what's even possible with Scrypto to begin with. And thank you so much for spending your time.
Yeah. Thank you for spending hearing about my Neuracle design and I also inviting you all to participate in building the paper. I'm on the paper phase right now. On the next phase, I will after we finalize the paper, we will I will implement a integrated test environment for people to test the Neuracle function. Everyone can test the Neuracle function, even smart contract operator, to see if it work on uh, on the integrated environment or not. For now, the new Neuracle, the current Neuracle design only work on unit testing, so I don't know if it will work on many computer, on many smart or the smart contract or not. So I'm inviting you all.
Yeah, well, keep us up to date, and I'm sure we'll have people to be helping out.
Yeah, please. If you have someone, just contact me. I'm to
Absolutely.
give. See ya.
Okay, thank you so much, Peter. Have a good one, man.
See ya, Austin.